Okay, so most of the hand and homeworks that I give in this class are things that you could just print out and write on if you want to, and that's true for this one too, except for the fact that you now know from Excel how to use Excel to make a nice looking bar graph. And so on this hand and homework, which isn't due, I mean, I need to talk about it today because you know how to do some of this. In other words, if I give you a list of data like I did over here on the side, you know how to make a bar graph from that now. Well, I should say that you're on your way to perfecting your ability to do that. Again, you're more than welcome to ask me questions about that. You don't know how to make a 5-number summary. We're doing that now. You do know how to find the mean and the standard deviation. Notice I said use your graphing calculator to do that. Like, that's way too many numbers to be finding the mean and the standard deviation yourself. Type all those numbers in your graphing calculator, or you have them in Excel already. Use Excel to do that. We will have a lab on how to do that, but I've shown you a couple examples just as a part of this class, I think. And then these last two are talking about things that you don't understand. But anyway, how to insert a graph. So it's like I have this open. If I go into some Excel, what am I doing? So if I'm in Excel and I made a bar graph, I think there's one sitting here. So notice that bar graph kind of moves around. It's like a picture that's over the top of Excel, if you will. So I can grab that. One option is to hit Control C on your calculator, but usually you can right click and say copy. So if I say copy, I just copied that picture right there. Now bring my Word document back up and right click, and notice you have some paste options. This is kind of important to stare at. If I paste this, I kind of get everything, but there's also one of the things that's kind of nice to paste is just a picture right there, because if you paste the whole thing, it's actually still like you can still actually change everything. You can change the colors and they don't want to move around as much. So I'm just going to select the picture, although I don't care how it got there. Well, notice now it's kind of ready to go, except for see how it's really big. So I can grab this corner and shrink it down to whatever size I want. And then that took up some space. So if I kind of backspace to get all the other things back onto one page again, now that I see how much room I have. And so here's kind of another thing. Do you see how the picture's in here, but I'm trying to actually grab it and move it. It won't move around. So here's some other skills that are cool for other classes. But one of the best things you can do, because I can grab the corner and resize it. But one of the things that's really cool to be able to do is click on it, right click, and this thing down here called wrap text. If you say tight, wrap text tight, do you see how now this is what happens kind of in a newspaper? In other words, if you have text, you want to type all around it. Now I can actually grab this and move it around, and do you see how the text wants to go around it? So I can now put it up here and I can kind of hit back return and kind of make some more space, however much space I want. I can make this thing a little bit bigger, kind of move it over to there. And so, you know, and again, actually the reason I'm having you do this is because if you are ever going to use this in some other class or in some other place in the world, which of course is the goal of a class like this, being able to make it in Excel and then put it back in Word where you can start typing again is probably the most useful skill. Shelley?
So I guess my question is, how do you get the hand and homework, like the file itself to open in Word?
If you go into My Open Math, it should just open.
It's open, but I'm not, it's like not in Word. I can't edit it.
Yeah, let's double check that. So this is not due till this Thursday. So you should know 2/3 of it right now and be working on that. And then the next day or so, I'll be showing you the rest of it. So if I say, and this is this might be a little different than what, oh, that's coming up as a PDF file. Yeah, that's in there saved as a PDF file. So I still should be able to do that though. So, I mean, one of two things. It is in there as a PDF file. So the fact that you couldn't open it as a Word, that's true because it came in as a PDF file. So I still could come in here and open that. And then you could print it after that and just write by hand for everything else you do if you wanted to, or you can type the rest of it. I don't care. And that's totally fine too. Like this isn't, yeah, print it off on a separate piece of paper and staple to it. Like I don't care. Yeah, so when you open it, you should have access to it. Yeah, let's leave it at that. Okay. Okay, so what do we need to talk about today? So one of the big things is something called a Z-score. It'd be great if I could write right now. Why can't I write? So something called a Z-score. And this is really neat and really powerful. Now, what you should understand from before with respect to the empirical rule is if somebody is plus or minus, if you take the mean plus or minus 1 standard deviation, do you remember how on the normal distribution, if this is the mean and you go 1 standard deviation above and 1 standard deviation below, we said that represented 68% of people would be within 1 standard deviation. So that kind of tells you where you are. If you are 1 standard deviation above the mean, you know that you're right there, plus 1 standard deviation. Right there, minus 1 standard deviation. Hello, welcome. And then secondly, we said the other day, what if you went even 1 more out from there? Plus 2 standard deviations. Or there, minus 2 standard deviations. I hope you have this memorized now, but we said collectively, all of that together represented 95% of people. And then we said outside of that was unusual. Does that make sense? So it wasn't an outlier. That's a word we'll be talking about today. It's not an outlier if you're outside of that, but it starts to be kind of unusual. Well, this is what a Z-score really is. This is a Z-score of +2. This is a Z-score of +1. In other words, what is a Z? Z is the number of standard deviations. Z equals the number of standard deviations . And it's important to understand that that's from the mean, from whatever the average is. And so this would actually be a Z-score of 0 because you're no standard deviations from the mean. You're right on the mean. And this would be a z-score of -1, and this would be a z-score of -2. So in this way, one number tells you exactly where you are with respect to everybody else. That's the powerful thing about a z-score. Now, please, listen super carefully. This is not something that we're just going to kind of mention quickly for one day and you'll never see again. Like, this is the entire rest of this class is built on this principle and on the normal distribution. And so what we said is, hey, look, cool, if you're within 2 standard deviations, that's 95%. But does it make sense that, you personally, let's say, you went and took a test or something like that, you're not going to be right on one of these lines. You understand that? Like, you're not going to be exactly 2 standard deviations above the mean. You might be like right here. You might be like 1.5 of them above that. Does that make sense? But that still actually tells you where you are. So, important concept. We said, if you're in here, anywhere in there, we kind of said that's usual. Therefore, if you're outside that, that's unusual. So a z-score is a number of standard deviations away. Now, this is one of the formulas on your formula sheet, and even one of the formulas we've been practicing on Mondays and Wednesdays. But this is the z-score formula. So scope this out on your note sheet. Maybe I'll pull this up in a second. But if you take your individual score minus the mean, and then you divide by the standard deviation. Remember, we have a number of symbols for these things, but if you divide by the standard deviation, that will tell you how many standard deviations you are away from something. And I'm going to kind of write this in my own language, but like that's you, that's what your score is. So let's play with this for a second. So does it make sense if the doctor came to me with respect to, say, cholesterol and said, you have a z-score of 2.2? Does it make sense I know where I am up there on that normal distribution? Notice I said 2.2, not -2.2. So since this is 2, then would you agree that a z-score of 2.2 is up there? It's like only one number. It's all you need to know is one number, and I know exactly where I am relative to other people. Now, because I'm more than 2, does it make sense I'm unusual? But I'm not way beyond 2. I could be at 3.7. I'm not way beyond 2, but I'm a little more than 2. So just from that number alone, if the doctor said your cholesterol score gives you a z-score of 2.2, that means I'm unusually high. Not unusual, but unusually high. What if I had a z-score of -2.4? That's still unusual because it's more than 2, but this time low. My cholesterol is unusually low. This is unusually high. Now, again, in the real world, does it make sense if a doctor said, hey, you have a z-score of 2.2? Your next question would be like, what the heck are you talking about? Like, people don't know what this means, right? So it's not as though this, kind of solves the problem, but the idea that with one number, you can know where you stand relative to other people, that's really kind of powerful. And again, this is the definition of when doctors start worrying about things. If your z-score is less than 2 or greater than -2, notice I didn't say less than or equal to, but basically between 2 and -2, then you're usual. You're usual. You're, inside that middle 95%. You're inside 2 standard deviations. If you're outside of that, then it starts to get unusual. If you're way outside of that, you might even be what statisticians call an outlier, like dangerous, or this would be really surprising. And again, a big part of the rest of this class is built on that. So let's make one calculation. Let's say, to use an example we've used a little bit, let's say that the mean temperature is, I think we said 98.6 degrees. And notice I said sample mean because I could be using the other symbol for that. Remember, the other symbol for mean is mu. So we're saying we think the mean is 98.6 and the standard deviation is 1.2, I think, the other day. And so those are fixed. You're stuck with those. That's data that you can collect and you can answer those yourself, right? I mean, you'd use machinery to do it, but you could collect data and come up with those two answers yourself. That's pretty powerful. But now what's kind of cool is now you can place any person that comes in. If you're the doctor, you can place any person that comes in entirely by just calculating their z-score to see if they're outside of 2. So you come in the door, some patient comes in the door, and they're at 101 degrees. And of course, you would say that's a high temperature, but you know, again, is that unusually high? Is that like let's get worried, let's put them in a nice bath, or is it like let's just watch it? Because you've probably been sick before, maybe even had kids that are sick, you probably have a sense of this just because you're a human being. But of course, I could be doing this for pollution or glucose, and you probably would have no idea, right? You wouldn't have any sense of it. So what does this formula up here say to do? Well, we want a z-score. So z-score is u, the individual number, minus the well-established mean, and then finally divided by the standard deviation. No such thing as math with letters, but this formula up here works for every person, for every situation. And now I'm putting numbers to it. Now, again, reason this out a little bit. Don't just push calculator buttons, but what am I getting if I take my calculator and I go 101 minus 98.6? 101 minus 98.6. I get 2.4. What does that tell? What does that tell me? What can the doctor tell me? Somebody put that into words. Yeah, my number is higher than the average, and so I'm 2.4 degrees higher than I'm supposed to be, which again is a normal thing to say, right? I mean, that'd be something you would want to know. Oh, you're 2.4 degrees over. Well, if you divide by the size of a standard deviation, then that tells you how many standard deviations that is. Because remember, by itself being off 2.4 doesn't tell you anything. It kind of depends on how much do people tend to deviate from the mean. So you know, based on the order of operations, that I've got to finish what's on top because of this giant division sign. It's like there's an invisible parenthesis up there. So I have to get that 2.4 first, and then I divide by 1.2 and I get 2. That's my z-score. So now I know something. Now, in a sense, the doctor knows something. Yeah, your temperature is high, but is it way high or is it just a little bit high? You don't get to just decide that yourself. Like, you have to think about that relative to this standard deviation here. Well, notice that tells you, and again, there's an implied, it's very important, that's like a positive 2, right? Not a negative 2. Doesn't that tell me exactly where I am over here? So let's think about that for just a second. Since I landed right here, I landed exactly on that line. Now, don't split hairs there. Does this mean you're unusual or not unusual? You're right on the line. If you understand that you're right on the line of being unusual, fine. This is not technically. This is somebody just decided, well, 95% seems like, you know, that's most people. Let's just pick that number. Like, why is it 95 and not 96? It could be 96. So we're on the line here of being unusual. But the point is this isn't dangerous. Does that make sense? The doctor, you and the doctor now know where you are. Oh, you're kind of getting close to being unusually high here, but you're okay. Let's take it again. Like, go home, take your temperature in a couple hours. If it keeps rising, okay, then we'll check it out and maybe do something about it. So I don't know about you, but I kind of have the sense like 105 sticks in my head is like, that's not good. If you're at 105, that's not good. Let's see what happens to somebody who's 105. And of course, when you go 105 minus 8.6, you get 6.4. And again, that's, you don't usually write it, but that just means you're 6.5 degrees over kind of a normal temperature, which again, doesn't mean anything until you divide by standard deviation. I'm going to erase this, but does it make sense if the standard deviation was 4? When you take 6 divided by 4, you get like 1.5. And so, oh yeah, no problem. Your z-score is less than 2. So just knowing you're 6 degrees over doesn't mean anything until you factor the standard deviation in. Well, our standard deviation isn't 4. It's actually normal to not vary by near that many degrees. We don't vary by 4 degrees from one another. We vary by around 1.2. Well, now when I divide 6.4 divided by 1.2, I get 5.3. That should stand out to you as like, wow, is that over 2? Yeah, it's not over 2, it's over 3. It's not over 3, it's over 4. It's not over 4, it's over 5. Like this is way out there. So if you have a z-score of 5, you are way, way higher than other people. Now remember, that could be good. That's how much money you have. All right, I got way more money than most people, but it could be bad. This is way, for now, this is way high. In the language of math, we're later going to say this is not just unusual. Anybody out there, anybody above 2 is unusual, but if you're that far above 2, you're not just unusual, you're an outlier. This is really strange. This never happens. Do you have a sense of what a z-score tells you then? So you figure this one out. What if somebody had kind of a low temperature? Like, anybody know what that's called? What's it called if you're like out in the cold and you get really, really cold and it's kind of like dangerous? Hypothermia, yeah. So your body temperature is only 95 degrees. Again, should we worry? So I've mentioned I'm on ski patrol. We get somebody in, we take their temperature and they're 95. Do I freak out? Or is it like, oh, that's a little low, you're fine? Does it make sense you can answer that mathematically? This isn't your opinion. This is you calculating a z-score. So what's the z-score for that? Notice there's an order to the subtraction. You don't just subtract any way you want to. It's always your score minus the mean. You don't switch them around because this time your temperature is lower than the mean. You don't switch them around because that tells you something really important. And this time when you subtracted, you got negative 3.6, which again, the 3.6 degrees is 3.6 degrees, but that tells you you're below temperature. Again, you already knew that, right? Based on common sense. Oh, I'm 95, I'm below. Yeah, the negative tells you you're 3.6 degrees below the average. And then again, by itself, that doesn't mean anything until you divide by the standard deviation. Whoa, we are -3. What does this mean? 3 standard deviations below, because of the negative, the mean. You got to understand what a z-score is. What does that tell you then if you're the doctor or the ski patroller? You're not inside that usual range. Like this is not just low. This is unusually low. And so this is a signal, oh, we better do something. We're not just going to sit there and watch them like we're going to put warm blankets on them We're going to get them in a warm room. If their clothes are wet, we're going to take their wet clothes off, put dry clothes on. We're going to do something to fix this, because this is not just, oh, maybe you're a little low. Do you understand? I'm going to erase this. But do you understand this is unusual? Yet, if this 1.2 had been something like 2.3, does it make sense? It wouldn't have been unusual? Like, it's totally dependent on what's typical to deviate. Totally depends, because what we're getting here is how many standard deviations is that? So z-score tells you how many standard deviations you are away from the mean. More than 2 either direction, unusual. So it totally depends. You can't know this until you come up with the standard deviation. So let's see. Let's look at a couple of things here. So notice that's one of the formulas on your formula sheet. You don't have to memorize that formula, but that needs to mean something to you. That's kind of the idea. I want to be able to ask you as your assignment will, what's the z-score for this person here? Like we just did a couple examples of it. What's this person's z-score and what does that mean? That's the kind of thing I would ask on a test. So by itself, when you stare at that formula, you should think, wow, that's really confusing. Not only is it confusing, it has X with a bar on it. What the heck does that mean? And then there's a Greek letter in it. And again, down below, I'm telling you all that stuff. Notice I told you Z is the number of standard deviations from the mean. And I even reminded you here that more than 2 is unusual. And now I'm telling you something that you didn't know before. More than 3 is actually considered an outlier. So if somebody's between 2 and 3, I would just tell them, oh, that's unusual. Let's put a blanket on you and something and maybe warm you up. But if you're more than 3, that's like now life-threatening or really dangerous. If they were life-threatening high, then we'd probably put them in an ice bath. Like they've got to get down right now or they're going to die. So between 2 and 3 is unusual. More than 3, outlier. So that one we had that was 5 a minute ago. More than 3 is an outlier. That wasn't more than 3. It was more than 4. It wasn't more than 4. It was more than 5. So if that was a health thing, that's huge. Does this mean something to you as far as outliers go? Can you read that statement? That's exactly what I just said. A z-score, and I kind of said this this isn't perfectly precise, but I said if your z-score is bigger than plus or minus 3, technically bigger than -3 is -2. But basically, if it's a number that's more than 3, whether it's positive or negative, now it's actually an outlier. That's one way to determine where somebody is relative to other people. Too much distracting stuff on here. Notice, as we said before, we didn't talk about this just now, but remember what plus or minus, how many people plus or minus 3 standard deviations catches? With respect to temperature, 99.7% of people would be within 3 standard deviations of the mean for anything. Blood glucose level, height, weight, shoe size. And so if you're not in that group, then there's only 0.3% of you, not 3%, 0.3%. That's not very many people. Does it make sense why somebody would say, yeah, that's pretty unusual now? There's not even 1% of you. And notice if you take 0.3% and you cut it in half, that's why in that 0.3%, there's only 0.15%. Half of 30 cents is 15 cents. So not only that, but of those people that aren't inside that group, there's half of them are kind of too low temperatures and half of them are too high temperatures. So that's why plus or minus 2 kind of tells you whether somebody is unusual. Just one number, it tells you exactly where you are relative to other people. And then plus or minus 3 tells you whether it's kind of worse than that. So let's think about this for a second. Let's see, what example do I want to do? Let's do this book one. I gotta pull this up for you guys that are online. This will take a second. So let me see if I can do it right now so everybody can see it. Yes. Okay, not super easy to see. If you're in the house, you're gonna get a piece of paper that shows this so you can look a little closer. But big picture, does it make sense that people write books and then they say, hey, let's sell those books? I wonder how much we should sell our book for. $10, should be 20, should be 30, 40, 50. So you might want to do some statistics to make that decision. How much should we charge? Well, I stole this off the internet, that the 75 top best-selling books at Amazon, and to get them all in there, to get them all into the same screen, and I put them in order here. Notice I couldn't just put them in a row with 75 because it would have went off the paper. So here's 25 down here at 1020, and then here's actually 26 up there at 1033. So you see what I did there? And so notice there's 3 25s there, so that is 75 books. Now, you tell me, I'm not asking you to read my mind here. So these are the top 75 based on Amazon. What did I do to get the mean and the standard deviation? What did I do? I cheated. I asked Excel to tell me, and I'm asking you to read my mind. Like, I didn't calculate that by hand. I'm not going to type 75 numbers in my calculator and add them all up like you crazy. So I've shown you in Excel, and we'll do a lab on this shortly, but I showed you there's actually a command called average. So I said equals average, and I grabbed all those numbers, and it said the average is 14.09. Now again, isn't that powerful? Because when you stare at those 75 numbers, it's overwhelming, right? And so to say, hey, the average price is 14.09. And so now I think to myself, okay, cool. So if I'm going to sell a book, then I should kind of hang out around 14.09. Right? I mean, that's kind of the idea. If I want to not be weird, then I should kind of stay in the vicinity of 14.09. But notice I went on and also had Excel, and we did this once, right? We found the standard deviation. Wouldn't that be fun to find the standard deviation by hand with 75 numbers? Wow, I mean, I can't even imagine that. So turned out, oh, it actually, remember, I was thinking I should hang out around 14.09. It actually was very typical. Do you understand what this means? I'm going to ask you this on a test. What does standard deviation mean? It's like, what's typical to vary from that? So notice there's tons of variation. Some people charged $5 for their book, and other people charged $18 for their book. And so there's variation, just like there'd be variation from temperatures, right? And notice this is not health. This is actually just a decision somebody made. And so does it speak to you when you discover the standard deviation is 4.92? Oh, so yeah, the average is like $14, but people, it was really typical for people to go up and down like $5 from that, right? So what you would say is, what you should be able to say from this then, if this was normally distributed, and we're not sure that they are, does it make sense I didn't make a graph? Does it make sense I'd have to make a graph of that as you've done in Excel and kind of see the shape to make sure that this was really true? But let's just play with it. If it was this shape, then if I went mean, and why am I using this symbol for mean? Why did I use that symbol and not the X bar?
Total mean,
That's the population. Like, isn't that the top 75 books? Like, there's no more. Like, that's all of them. So this is actually the right answer. Now, it's not the mean for all books that were for sale. Then I would have to say I just took a sample. But if I take the mean plus or minus 1 standard deviation, and I'm going to get it exactly right instead of just kind of round it off. That gives me a range of $19.01 at the top end, all the way down to, oops. All the way down to 917. I just went 1409 plus 492 and 1409 minus 192. And that's part of the reason I'm doing this. And thank you for just speaking up. That's why we're doing this. I'm not doing this to demonstrate I understand it. I'm doing it to help you guys get a conceptual understanding of this. I took the mean and I first added 1 standard deviation to it. And then second, I subtracted. Out of laziness, we write plus or minus because you're going to do both. So do you agree that that would represent 68% of the books that were sold then? See how powerful it is? I only know those two numbers because I can't stare at all 75 of the other ones. And so now I know if I'm going to price my book, my gut thought is I should stay somewhere in there. Now, if I think I'm pretty awesome, then maybe I'll pick this side of that range. If I'm like, I don't want to overpromise and underdeliver, I think I'll stay down here. Basically, it wasn't weird to vary from the mean by 492. Therefore, this takes care of, well, roughly 2/3 of the books that were for sale. So if I stay in there, I'm not in danger of being weird, right? Keep in mind, why am I doing this? I don't want to charge too low because I'd like to make lots of money, but I don't want to charge so high that nobody wants my book. So rather than just picking something randomly, I'm doing statistics. I'm trying to make a decision for myself. I'm not just reporting on the past. I'm trying to decide what to charge for my book. So what if somebody said, well, let's go plus or minus 2 standard deviations? That takes me a little further out. Well, that takes you all the way down to 425, but all the way up, and double check this on your calculator. Make sure you can do this and speak up immediately if you cannot. That gets it a little bit wider. That throws the net a little bit wider, right? Now, if I stay inside there, I'm still, well, what we call usual. But do you agree if I decide to charge $23.93 for my book, I'm pushing it because I'm getting to the level of maybe being unusually high. But I can still say, yeah, I'm unusual, but I want to make money. I'm going to charge $22. Can you see a person just making that decision from here? I think I'm pretty awesome. I don't want to be crazy. I don't want to, but it's like, I'm going to stay inside usual, but I'm going to go $22. That's really high, but it's not way high. Do you agree that outside that now is unusual? Do we have any of those? Any people charge an unusual amount for their book? Notice not unusually low, because wouldn't we have had to be below 425? But were there some unusually highs? Lauren says yes, she's correct. How many unusually high? Yeah, those 3. Now they were bestsellers, right? So that actually means they probably made a good decision because they were still a bestseller. If you charge too much and then they didn't sell, it's probably because you charged too much. My guess is those were established authors, like people already liked them or they're part of a book series or something like that. But isn't that interesting that those 3 people, if you will, based on these statistics said, I'm that good. But you see why this is kind of cool? Because you're actually, if you enter this market now, you can actually make an intelligent decision about where you should be. Again, we're talking about predicting the future. Now, out of curiosity, from what I just showed you, could you take that highest value right there and you calculate their Z-score? So we know their z-scores above 2. Do you agree with that? Because they're above 23.93. So we know their z-scores more than 2. But is it going to be like 2.9, which would be unusual, but not an outlier? Or is it actually into the 3s? Is that even an outlier high? Was that a crazy decision on their part? Can you come up with that z-score? So formula, your score, the number that you're interested in, minus the mean, divided by the standard deviation. I did hear the right answer out there, but I'm just giving people time to think. When you subtract those on the top, you get 1561. Again, you should understand what that is. That tells you this person charged 15 bucks and 60 cents over the mean, like almost double. In other words, they charged double for their book. Wow, it's a positive number. Doesn't mean much until you divide by the standard deviation, and you do get about 3.17. So not only is that person high, they're an outlier high. Yet, good for them, it's still in the bestseller list, so they made a ton of money. In a sense, I bet in hindsight, they're pretty glad they didn't hang out at the bottom and charge $6 a book, all right? Because they still would have sold a lot of them, but they're still in the bestseller list, and they charged an outlier high. So if I'm like, I wrote my first book, and I was like, what am I going to charge? I think I'll charge $29.70. No, you're dumb. That is an outlier high. Nobody knows who you are as an author. That's kind of dangerous territory to be in. Now, here's an interesting question. What if you actually knew? What if you were curious about a z-score of 3? Would you agree that since this person was 3.17, a z-score of 3 must have been a little below this, like maybe $29 or $29.10 or something like that? What if you were curious about that? In other words, let's work this backwards. And we've been practicing a little bit solving equations. What if we wanted to use this formula for a different purpose? Because you said, I don't want to be an outlier. Like, I don't want to be higher than 3. I want to be less than 3 so that I'm not an outlier, but I want to be way up there because I'm hoping to make a lot of money at this. And so I'd like to know what number defines a z-score of 3. Well, think about what you know. Does it make sense? This time you don't know the individual score, but you still know the mean and you still know the standard deviation. The question is, could you solve that equation? Notice it's worse. Like, this is the same formula, but it's not, we're using it for something it wasn't designed for. Stare back at the second one for a second. This one we calculated. Notice that's exactly what this equation is designed to do, is spit out a z-score. And we knew all 3 ingredients. Whereas this one's kind of working in reverse, saying, I know what recipe I'd like to make, but I don't know what ingredients to stick into it. Now, could you just guess? Based on common sense, you know that $29.70 was 3.17. And so could you just guess and say, oh, I'll try $29.40 and see what you get? And just keep trying stuff until you got it? Yeah, you could do that. If you weren't good at algebra, or if you were stuck on something, you should have the creativity to say, well, I know how to do this. And so I'll just guess and guess and guess until I get it pretty close. That's not a terrible strategy. But it's kind of a waste of time. So we'd like to find X. And I like to think of that as, I need the 2 numbers there gone. Don't I need this number to be gone and I need that number to be gone? And then wouldn't the X be by itself? So as I said before, this is the opposite of wrapping the present. I've got to unwrap it. I've got to get rid of those things. Well, a second ago, did you not do that first? And then this second, wasn't that the order that it needed to be done in? So because we're undoing this, that means we need to take care of this actually first. So if you can look at this and say, hey, look, this is all being divided by 4.92, then how do you get rid of 4.92? What's the opposite of dividing by 4.92? Multiplying it. In other words, this is the way a mathematician would write this. If I multiply both sides by 4.92, 4.92 divided by 4.92 is 1. That's why it gets rid of it. So that effectively got rid of it on the right side. And now on the left, I'm just going to have a different number. 3 times 4.92 is 14.76. And now this side only has this left on it. You see I'm making progress? I'm getting x by itself. I'm wanting to figure out what x is equal to. Remember, I already know the answer is a little less than $29.70. And so now I'm attacking, doing this backwards, I'm attacking that operation. Say it out loud. That's x minus 14.09. So what's the opposite of subtracting 14.09? Add it. So I'm going to add 1409 to this side. I'm going to add 1409 to that side. If you add and subtract, doesn't that get rid of it? It goes to 0. I'm basically adding nothing. If I have a wallet and I add $5 and I subtract $5, I'm back to 0 again. And so mission accomplished. I've got x by itself. All I have to do is do what math is on the other side. I've got to add it over there too. I end up with $28.85. Notice that seems reasonable. Remember my guesses before, notice my guesses were wrong. I said, I think I might try $29.40 or something like that. I wasn't guessing low enough. So I could have guessed it eventually, but it would have taken forever. So now I'm going to check my work. I'm going to put in 28.85, subtract 14.09, like do the normal, this order here. I'm just replacing this number with the answer we just got. 28.85 minus 14.09 is 14.76. I divide that by 492. Hey, I got 3. I got a z-score of 3. It worked. If you're not confident with this, check. What z-score would I get if I took 28.85 minus 14.09 divided by 492? Check. I got 3. Got what I was supposed to get. Cool. I'm better at doing math forwards than backwards. You should find the red calculation there is, less comfortable unless you just happen to be really good at algebra. But again, that's not a weird question. In other words, if I'm writing a book and I say, okay, I want to charge a lot because I want to make a lot of money, but I don't want to be crazy. So 3 as a z-score would be crazy. If I go beyond that, I'm an outlier. And so look, I just found the line, 28.85. Does it make sense? I could say, okay, well, I'm going to back off of that just a little bit. I'm going to charge 28 bucks. And so I'm high, but I'm not unusually high. Huge idea. Okay, we are out of time already. We've got to talk about something called a 5-number summary. So save the sheet that I just gave you because we'll pick it up there. We'll pick it up there tomorrow. And as always, stay after if you have questions that you want to ask.